Okay, so now we are going to look at physical sciences paper 2 multiple choice questions, number 4. Okay, so 1.1, which formula shows the way in which atoms are bonded in a molecule but does not show all the bond lines? Okay, so show the way in which atoms are bonded. That is definitely not an empirical or a molecular. Remember, a molecular and an empirical only shows us which atoms are there and how many there are of each. So empirical being the simplest, molecular all of them the way they are, but doesn't show the way they are bonded. So this leaves our options to C and D. So now they say the bond lines are not shown, but we know that it's for a structural, the bond lines are indeed shown, right? So it means the correct answer there will be D. C is wrong because they said no. If they said the bond lines are shown, the answer would have been C, structural. But the fact that the bond lines are not shown, it means, well, C is wrong, and the right answer there is going to be D. 1.2, which one of the following compounds has hydrogen bonds between its molecules? That shouldn't be difficult. We know that hydrogen bonds is only what? Alcohols and carboxylic acids. Okay, so there we are going to look for a carboxylic acid or an alcohol. So A, well, A is only single bonds. Okay, so 3 plus 2 plus 2 plus 3, that is 10, right? And okay, see, A kind of looks like an alkane. Either way, it is wrong because there's no OH there. There's no OH, and carboxylic acids and um, alcohols, they have that OH, which is a requirement for an hydrogen bond. Remember, hydrogen bond, hydrogen needs to be bonded to either oxygen, nitrogen, or fluoride. So there is totally out. B, there is an oxygen, but that oxygen is kind of alone, so I'm guessing they C on the other side, so that looks like a keton, right? All right, had it been alone there at the end, we'll say, I'll assume that it's an aldehyde, but the fact that it is in the middle, and that looks like a keton. Then C, two O's, two oxygens, that could have been a carboxylic acid, but in this case, carboxylic acid, we know that the two O's happen to be at the edges, right? The last or the first carbon. So in this case, it cannot. So that is definitely an ester, not a carboxylic acid. They look alike though. Remember, they are functional isomers after all, but that is definitely not a carboxylic acid. When you look at D, there's an OH in the middle, and they've put brackets around it to show that it's an OH, so that is definitely an alcohol. And remember what we said, hydrogen bonds, we find them in alcohols and carboxylic acids, so definitely the answer there is D. 1.3, consider the compound below. All right, so when they say which one of the following is the IUPAC name of this compound, okay, IUPAC naming, you need to first notice which homologous series are we talking of, and that depends on the functional group. So you observe the functional group there, that is definitely a carbonyl functional group, because the double CO bond is in the middle. So that makes it a keton, right? Had it been at the H's, we'll assume that it is an aldehyde, but the fact that it is in the middle, that is a keton, and we cannot rule out any of them because all of them, the options they've given us are ketones. Okay, then what's the next thing? We need to choose the longest chain, but then when you have a functional group such as this, we need to make sure that that carbonyl has the lowest position possible, right? So if we have an option of saying at one case it is in position 4, in the other case it is in position, like here we have one case where it is in position 2 and another case where it is in position 3, we need one which is kind of less. I'm not saying the 2 is going to be correct, but remember, longest chain, but the position needs to be kind of less as well if we have such options. So the longest chain there is 1, 2, 3, 4, 5 carbons. Okay, great. So this has to be a pentanone, right? So we count where is the position of our carbonyl, from the right hand side it is position 3, from the left hand side it is position 3. So that brings us down to two options. We are now left with A and B. C is completely wrong. D is definitely completely wrong. All right. So between A and B, which one is right? Both of them are pentane 3 on, but now you see the position of the methyl is the one that is different. So now in naming, you need to make sure that your substituents are also in their lowest positions if possible. So if we count from the right hand side, the carbonyl is in position 3, but that makes the methyl to be in position 4. But if we count from the left hand side, we remember our priority still remains on the carbonyl. The carbonyl needs to be in 3. So however, when we move from the left, we find that the methyl substituent is now in position 2, and that is what we want. We want it to be at the lowest as well. Yeah, so in this case, the correct answer is definitely going to be A. 1.4, a 2-gram piece of magnesium reacts with excess hydrochloric acid according to the following balanced equation. Okay, balanced. Which one of the following changes will increase the yield of H2? A, crush the pieces of magnesium. Okay, that sounds right, but why isn't it right? Because remember, crushing the pieces of magnesium can only increase the rate of this reaction. That won't increase the yield. So the rate of reaction will definitely increase but that won't. Remember the surface area, effective collisions, all that will apply there. But in this case, they want the yield of H2 that is produced. So A is out. B, use a 3-gram piece of magnesium. There we had 2, here 3. B sounds right so far. C, use a greater volume of acid. Okay, now volume, pressure, that could have applied, but in this case, this is not a gas. Yeah, so in this case, that won't apply. That won't apply, and this is not a reversible reaction after all. Yeah, so that one is out. D, use a higher concentration of the acid. Okay, the acid is already high, but either way, if we're going to increase its concentration, that would probably increase what? The rate of the reaction either way. But so in this case, already in excess as well. So yeah, so the correct answer there is definitely going to be B. 1.5, the Maxwell-Boltzmann distribution curve P represents the number of molecules against kinetic energy for a certain reaction. Curve Q is obtained after a change was made to one reaction condition. So P, Q, Q just happens to be kind of have a larger area compared to P, meaning remember the white section in the Maxwell-Boltzmann is the number of molecules, particles. So in Q, there are more particles than in P, right? So, and yeah, so we see that the number of particles are the ones that changed. So definitely that has to be what? Increase in the concentration of the reactants. Had it been addition of a catalyst, then we were supposed to see a shift in the EA, the activation energy. So that's definitely not the case. So A is wrong. B, increase in temperature. Had it been increase in temperature, then we are supposed to see a shift, all right? So P was supposed to like shift. We're going to see the same number of particles, molecules, but we'll see an increase there in the number of particles that have energy that is greater than the activation energy, and that is not the case. So the number of particles are the ones that increase. So it's concentration increase in activation energy. Well, that doesn't even make sense in this context. So that is definitely wrong. 1.6, we are told the expression for equilibrium constant for a hypothetical reaction is given as follows. Kc is equals to the product x cubed y squared down z's. Okay, which one of the following equations of the reaction at equilibrium matches the above expression? All right, so what do we know about Kc? We know that it's products on top, reactants below. The powers represent the coefficients of our letters. Okay, so when you look at A, they said Z, so the coefficient is 1. When you look at the expression, the power is 1. Fine. When you look at Y, the coefficient is 2, and there in our expression, the power is 2. Good. When you look at X, this is 3, and on top there is also 3. All right, so A looks right. B, we look at B, Z, 1, 2y, great. Then 3x, good, looks right as well. C, Z, there's y, no, the y is wrong because the coefficient is the one that is supposed to be equivalent to the power there. So C is totally wrong, right? Then you look at D, Z, 2y, okay. Good, 3x, yes. Q, where did the Q come from? No? So now we probably think that it is wrong, right? But then now let's go back to A. We said A might be right, but then when you observe in the KC, remember the rules of the KC is that we do not put the concentration of solids and liquids in that expression, and X there has been given as a solid. So if it is a solid, then the expression for that equation wouldn't be the one that we are shown above, because the one we are shown above has x, so x is not supposed to be there if we are considering equation A. So A is wrong. Similarly, B is also wrong because they took X as a liquid, and remember we do not put the concentration of a liquid in our KC expression, so B is definitely wrong. Now C, we said it is wrong, so the answer now looks like it is D. But D, we asked, why there is a Q there? Where did the Q come from? And it is not there in the expression. Well, that doesn't matter because the Q, even though it has been shown in D, it is shown as a solid, meaning that when we are trying to get the KC of that equation, the Q will not be put there. The concentration of Q wouldn't be included there because it's basically 1, so it wouldn't be shown there. So either way, that's the case, so it means D is the right answer. 1.7, two dilute acids of equal concentrations are added to separate test tubes as shown below. So we have HCl and we have CH3COOH. Consider the following statements regarding these acids. Number 1, the pH of each is less than 7. That is true, both of them are acids. Acids have a pH that is less than 7, bases greater than 7, so both are acids, so option 1 is correct. So we look down there, anything with option 1 can be considered correct. Anything without option 1 is definitely wrong, so D is definitely wrong. Then we look at option 2, both will react at the same rate with 5 grams of magnesium powder. Alright, so that one kind of looks correct, but then we observe HCl is a strong acid, then the other is a weak acid. So weak acids and strong acids, how do they differ? We know that HCl, strong acids, they ionize completely, right? Then the other ionize partially. So meaning that in this case, HCl, since it ionizes completely, its rate has to be higher than that of CH3COO, which is kind of like ethanoic acid, acetic acid. So number 2 is wrong. Anything with option 2 can be considered wrong at this point. So B is out. We are not going to consider B there. So we are left with A and C. So they said both will neutralize the same number of moles of sodium hydroxide. Well, since HCl is it is monoprotic and the other is monoprotic as well, in this case, even if we try write down the equation of the reaction of HCl with sodium hydroxide, and you also show the one of ethanoic acid with sodium hydroxide, you'll realize that the ratio will be maintained as 1:1:1, and if the mole ratio is the same, then it means the moles that they react with sodium hydroxide are the same. So it means 3 is also correct, which makes our answer to be basically C. Which one of the following is the conjugate base of H2PO4 minus? Conjugate base, alright, so if it's a conjugate base, it means that this is an acid, right? If they're asking us of the conjugate base of this, it means we assume that this is an acid. So how does an acid form its conjugate base? It forms its conjugate base when it donates a proton. So in this case, we expect this one to donate a proton, right? So if it donates a proton, -1H. So we are looking for options which have, okay, so is it A? Well, A could have been right, but then we want to donate a single proton for now, not all two. Then B looks kind of right because we now have 1H. And the charge, yes, indeed, the charge needs to kind of become more negative because we've lost a positive proton, right? So B kind of looks right. C, definitely wrong, because C would be what? C is kind of like, if we assume that this is a base, right? And we assume that it has gained a proton, but now how can you have a conjugate base of a base? That doesn't make sense, right? So this C is wrong. Then D, no ways. So D is wrong, definitely. So the answer there will definitely have to be B. 1.9, the diagram below shows a voltaic cell, that is a galvanic cell. Which one of the following correctly describes the movement of ions in the cell? Are we concerned with zinc and copper? Okay, movement from one cell to the other, Y to X. Well, anything with copper has to be wrong, or anything with zinc, right? So those are definitely wrong. Let's see now. In the salt bridge, we have KCl. It's there obviously to maintain some neutrality. So where will the ions form? So move. So we have Cl and K. So those are options. Those are the ones that you need to look at. So is it Cl minus or is it K? And both of them, they're given as Y to X. So B and C are definitely wrong. A and D, kind of, one of them has to be right. So now we need to know where Cl will go. So chlorine ions, when that split, the chlorine ions need to move to a half cell that it basically contains positive ions, right? So which, and then the positive potassium needs to go to a half cell that contains negative ions. Okay, so when we look at all right, so if we look at zinc, between zinc and copper, which one undergoes oxidation? Because the one that undergoes oxidation forms what? It forms positive ions, right? And then forms positive ions. That positive ion will need to be like react or kind of with the bind with the negative chloride. Okay, so assuming chloride in that case, then the one that undergoes reduction, of course, the reduction, we are forming the metal or whatever. So in this case, let's look for the one that undergoes oxidation. So now between zinc and copper, the one that undergoes oxidation is definitely zinc. You can use your table. You'll see zinc is above copper. It is a stronger reducing agent than copper. So meaning that, and remember, the stronger the reducing agent, it means it undergoes oxidation. So zinc undergoes oxidation, forming zinc positive 2 ions, and those will definitely want to react or bind to the chlorine, negative chlorine ions. So in this case, if on the left we are forming positives, it means chlorine needs to move from Y to X. So the answer there is definitely A. Then the last question, 1.10, the diagram below shows a cell that is used for the refining of copper. Which one of the following statements is true? Number 1, X is made of platinum. Nope. The mass of X increases. Well, that kind of sounds right. The X is the electrode where oxidation takes place. Nope. Oxidation needs to take place at the anode. The anode is the one where we have the impure substance. So the impure copper, that's the anode. That's where oxidation needs to take place. Then they say DX is connected to the positive terminal of the power supply. What is connected to the positive power supply? Okay, that is definitely the anode, right? So that will be wrong there. So the correct answer is definitely going to be B. Yeah, so B is the correct answer. Yeah, and that is it.